Hey folks, and how are you doing today? Now, welcome to this episode of The Grow Show, where we talk to people about their businesses, their communities, their passions, and we learn little hints and tips and a little bit more about what they do to help you in your everyday life. And today, I am joined by two people who I've literally just met today, a guy called Brad and a lady called Trisha. And we're going to be talking all about 3D printing and about their business and community, Virtual Foundry. Now, I'm going to bring them into screen so we can have a little chat about it. But in the comments below, or if you're listening, or if you want to get in contact with these guys, please do, because I'm coming from it from a very beginner's point of view. So if you've got any individual questions which are really advanced, get in touch with them. The details will be in the show notes and also at the end of the show. So I'm going to bring Brad in first, and then I'm bringing Trisha as well. So Brad, Trisha, thank you very much for joining me today. How are you doing?
Sure. Great. Doing really well, Gary. Thank you.
Yeah, doing good.
Cool. So just for the people who don't know, tell us a little bit about Foundry Wood, Brad. Tell us a little bit about it, and then, and how you got started before we move into the whole 3D printing. So I can imagine that's going to be a big can of worms that we'll have a chat about.
Sure.
Right. Sure. This was a project that I started in my basement in 2014. It really became a passion project, coming up with methods of fabricating metal objects. I wanted to be able to sculpt in metal without having to use a foundry, hence the Virtual Foundry. And this is a quest I actually started over 20 years ago. But when 3D printing came along, I was working on with some techniques for that process that I thought I could adapt to 3D printing. And that's the foundational technology of the Virtual Foundry is exactly that. So it's a powdered metallurgical process, it's called, and we use a technique called sintering.
So Trisha, can you tell us a little bit about sintering in that case? Because that's a term that I'm not familiar with.
Sure. Sintering is a later step in the process of using our materials. You use sintering with powdered materials. It's commonly used with metal, but it can be with other materials as well. So if you have a powder and you heat it to the point where the edges of the powder start to fuse together. So they're not actually melting together. It's just those edges melting a little bit and then coming together. So think about a bowl of hard candy in the sun. You can imagine how the candy starts to stick together, but it doesn't become one glob. There are still those individual pieces, but they are all stuck together as those edges come together.
Really nice picture, and I can imagine that now. Yeah. So from kind of a novice point of view, 3D printing, I've heard about it, and I've heard different people talk about it over the last probably 5 or so years. Yeah. I don't think I've heard anyone talk about it when you set it up, Brad, back in 2014. I think were you one of the early adopters, or has it been going on for much longer than I?
Yeah, it existed on an industrial scale probably since the 80s. Some of these technologies are quite old, but what had started happening around the mid 2000s is some of the early patents started expiring on those early technologies. And hobbyists started picking them up and developing methods of using that technology in a sort of a homebrew type strategy. So this definitely started out as a DIY movement. Yeah, so very grassroots project. But by 2015, it was gaining a fair amount of momentum and becoming more and more commercial. So it started out as an industrial application, became a hobbyist application, and then melded back into an industrial application. It's kind of an interesting story.
Nice. And Trisha, I believe we got a video, haven't we, to play? For the people who are watching it on YouTube, happy days, you could be able to see it. People who aren't watching it on YouTube, well, sucks to be you, and you're not going to be able to watch it. So jump onto YouTube if you do want to see it. It's not that long, but it shows the process really, really. So I'm going to add it to stage now if you don't mind, and then the controls are all yours.
Sure. The video is showing an up close of an object being printed. So 3D printing is synonymous with additive manufacturing. So you're adding material to build an object. We all know about subtractive manufacturing or milling, where you take a block of material and you carve away to create a shape. With additive manufacturing or 3D printing, you're adding material. So what we see here is a close-up of the actual part of the 3D printer that is laying down the material layer by layer. So let's take a look. Now this is time lapse. It is very much sped up. 3D printers don't actually go this fast, but it gives you an idea of how it's building the object layer by layer to get to the top.
Brilliant. And is there certain items that people tend to kind of associate with 3D printing in terms of, is there certain items people tend to associate with printing?
Well, 3D printing just opens up a whole world of new shapes that haven't been available through traditional manufacturing means. So the shape that we saw on the video, that little boat, is called 3D benchy, and that is a common shape in the 3D printing world. It's used to test the capabilities of your printer. Brad's got one right there. So it's used to test the capabilities of your printer. It has some unique features in there that let you know what your 3D printer is capable of doing. So that is one common shape that people use a lot. Otherwise, sky's the limit. It is wide open. There's a website called thingiverse.com, and there are others like it that host thousands, possibly millions of models that you can download and then 3D print yourself. So nearly everything is available to be 3D printed.
And at the start, Brad, what were you kind of printing compared to what you're printing now?
My first thought was, a friend of mine gave me an inexpensive, one of the first consumer grade 3D printers that you could afford to buy. It was maybe $400 or $500, and it was made out of plywood and zip ties. And a friend of mine said, "You got to check this out. This looks like your kind of thing." So I set it up, got it working. It came as just a box of parts as a kit. So it took me a couple of weeks to get it going. Once I finally did, I printed a part in plastic, and it just seemed disappointing. I mean, it was a miracle that you can just make any shape, any arbitrary shape that you choose. That was incredible. But my first thought was that for it to be relevant, we needed some better materials, and metal, which I was already working on for other applications, sort of merged the two technologies, and it went from there. So literally, when I started, I was just looking for interesting things to 3D print, which is what most people do when they're getting started.
Nice. And what does a common person kind of make with it? Because obviously you say the sky's the limit, so you can make pretty much anything.
Yep.
Do you kind of tend to get what? Yeah. Does that mean, let's say if my cup breaks, my handle breaks off my cup, I could make a new cup?
You certainly could.
Made out of plastic, but that would be the principle.
It would be an expensive cup, and it would take you a lot of time to make.
So you're limited by size at the moment in terms of the time and energy.
You can print as big as you want. There are applications where they're printing cars, things like that. Not houses, yep. Right? That's a good example. 3D printing in construction is going to be revolutionary. It just makes so much sense. In the same way that we're using plastic and metal here in construction, they just use concrete. It's just not complex. So they're able to build up the walls and frame of a house in a day or two. So a lot of this is just in its infancy. It's just starting to make sense. And a lot of it doesn't make sense for people that are at home if it isn't something that interests you. So a lot of the industry continues to be at a hobbyist grade, but that's changing quickly. So our key customers are people in research and education. This is the vast bulk of our customers are there. Some of it in defense, some of it in decorative items. Like we have a museum in Italy that uses our material to print pieces in copper and bronze for their gift shop, things like that.
Wow, I never actually thought about it as a kind of a way to create art in terms of that. But actually, I suppose when you said that, the sky's the limit, you can make anything that's, particular shape. that certainly blends itself to 3D printing and to art, where
Yes.
the physical kind of limitations that we might have because of technology, because of the machinery or our skill level, well, that's kind of with 3D printing, potentially that could disappear.
I think you can change art or make it more accessible. And like I said, my original vision was to make a virtual foundry, to make methods of metal fabrication that weren't accessible to the typical person. Most people don't want to melt and pour bronze. I do, but not everyone does.
I look at it too like graphic design. So graphic design didn't replace drawing or painting. It just became a new art form. So this will do the same. So 3D printing isn't going to replace anything that's happening right now. It just adds a new way to do things.
Yeah, and this is a common misunderstanding about the industry. People tend to picture that you're going to 3D print, for example, the trailer hitch on your car, and that's ridiculous. That doesn't make sense. The place where 3D printing starts to make sense is for unique objects. You don't want to 3D print 1,000,000 parts. That isn't going to make sense. But if you needed to make 1,000,000 parts that were slightly different than each other, then it makes sense.
Gotcha.
The other place it comes into play is we have customers in nuclear power. So they need to build shielding pieces that go on specific plumbing inside of this massively complex nuclear reactor. So it does make sense to print a part, even if it's going to take a day, where the alternative would be ordering it and you're not going to get it for 3-4 weeks.
That makes sense. And how large are, and I suppose this is relevant, this depends on what you're building and what you're designing, but how large is the hardware? Is it quite small? Is it portable? Or, but I'm guessing the answer could be depends on what you're building.
The printer itself, you mean?
Yeah, the printer itself.
Yeah, there's one on Trisha's over her left shoulder there.
Yep, right here.
This is a very
That's
small
printer. Yeah.
Yeah, that's a very small one, but that's a good example. And the concepts are all sort of open architecture. There's nothing special about it. You can go buy these. I mean, there's simple robotics tools that you can buy off of eBay and Amazon and things like that. So people are they're just building their own 3D printers to whatever scale they need for whatever application they're working on.
3D printers range in price from a couple $100 up to tens of thousands of dollars. It depends on what you want out of your 3D printer, how big you want it to be. There are a lot of different features that companies add in to make 3D printing easier. So as far as size, they really range. You can get 3D printers that are 1 meter square build plate. So there's a really wide range of equipment available there, and our materials will work in that full range of 3D printers. So Brad created a product that is equipment agnostic. So it's going to work in any brand of 3D printer. It needs to be the FFF, fused filament fabrication style of 3D printer, which is this style that I have here. And it is also the most common type of 3D printer. Common brands, Creality, Bamboo Lab that we saw in the video, Ultimaker, Prusa. So that style of 3D printer, our materials are going to work in that broad range.
Right. Any printer that uses filament will print our product. And yeah.
Nice. And you've mentioned that people have been using different materials, so copper, bronze, and then kind of the different kind of types of plastics there as well. But what other kind of materials can people print? And again, please tell me if this is a stupid question, because I just don't know. So I'm going to ask these kind of questions because I'm nosy. I want to find out. So in terms of kind of what other materials there are, and am I right in thinking, as a follow-up question to that, medical people using it in the medical kind of services as well, potentially to create kind of different bits and bobs to put into the human body? I'm sure I've read that somewhere. I can't have made that up.
No, absolutely.
You didn't. In general, 3D printing, there are all kinds of materials available. A wide range of plastics, to be sure. Some of them are higher temperature, some of them are flexible. So a wide range of plastics. People are also 3D printing with wood filaments, nylon. So there's a wide range. Here at the Virtual Foundry, we're really focused on 3 types: metal, ceramic, and glass. So that's what we're doing around here. Now, you talked about medical implants, and yes, absolutely, that is happening today. So people are 3D printing custom knee replacements, for example. They're not doing that with copper for sure, but there are other ways of 3D printing and other materials that are suitable to be implanted into the human body. That is already happening.
And what's unique about the Virtual Foundry's materials and our process is the cost and accessibility. So a lot of the things that you're talking about, so things like a biocompatible titanium knee implant or a jaw implant or something like that, is currently done on a printer that costs millions of dollars. But we have people working on and developing systems using our incredibly inexpensive technology to accomplish roughly the same thing. So there will be a point where you'll be able to print biocompatible parts on inexpensive printers. Obviously, you're not going to do that at home, but we can. But it's becoming more affordable, and we see this in a lot of less developed economies, things like that overseas. They're very interested. This would be a game changer for people without good access to high-end medical care.
I love it. And one thing that I'm a firm believer of is that technology can be used for great things, can be used for bad things at the same time. And that's all down to obviously the user and their motives and all that kind of stuff. So when I hear about new technology, like 3D printing for me or AI, for me, it's a tool, and it's a tool that should be embraced, and it should be used for the positive good. But that's obviously my motives come through. Yeah. So when you say about actually being using in the third world country, straight away I go, fantastic. That's brilliant to kind of do that. And yeah, I'm guessing nobody would decide to print a 3D kind of knee implant at home. I can't see that being useful. Maybe a figurine of something. Maybe I can see that, but not a knee implant. I can't. Yeah, but again, that could just be my kind of narrow-mindedness going through and thinking, actually, I need a new kneecap. I'll print one at home. I can't see that happening myself.
Well, maybe if you go in for all the scans and they make a model of your heart, you could 3D print one at home to put on your mantle.
Okay, I'll give you that one. I can see that as a memento, I suppose, of it.
Yeah, this is kind of fun, actually. There are people doing this at the hobbyist level. You go in, and when you get a CT scan or an MRI, it actually develops a 3D model of the inside of your body. So people will ask for this on a CD that they take home and then make a 3D model of some part of their body and then 3D print it.
See, in my mind, I'm just thinking to myself, if I said to my other half that, okay, I need a 3D printer to start off with, but tell you what, this is a great opportunity for me to 3D print my heart now. I've got this. I've got it.
Now we're joking about it, but they do make 3D printed organs to practice on, right? So if you think about a pediatric surgeon and you've got a premature baby, you can make an analog substitute of an organ in that baby to practice on, to see what that looks like before you go into the actual surgery. So that is something that's in use today. So that's a very exciting use of 3D printing.
Yeah, I can see that, and I've heard people use virtual reality and AR to be able to kind of do that, where they go, especially the fire systems in the UK, they are trained using VR so they can experience what's happening there. So I can see that as a training method. That's completely just. Is there any kind of misconceptions that you want to kind of bust? Because obviously we're talking at quite a base level, and at a base level, most people will have some views of actually we can print this or we can print that. But actually, in reality, as you deal with it every day, what are some of the misconceptions that we should be aware of kind of the industry?
Yeah, and some of this may be my opinion, but people tend to picture the growth of 3D printing replacing other types of manufacturing. And this will happen in a narrow space, but it isn't going to be a situation where everything is 3D printed. That doesn't make sense. And the niche where 3D printing fits best is if you're competing with time. Like if you need a part and it costs you $10,000 a day in downtime, well, then the part is priceless if you can print it in your own shop. So in that narrow scope, that's the best place for it. But not everything is going to be 3D printed.
So another idea that folks have is they've got a part that they typically have machined, and they want to 3D print that exact same part. Well, that part was designed specifically to be machined. The part was designed to be made in that way. That doesn't translate. That's not a one-to-one translation for 3D printing. That shape won't be the best suited for 3D printing. So if you're already making a part, you've already got an established way of making a part, keep making it that way. If you want to use 3D printing, change your part, lightweight it, make it better, make it more suitable for the 3D printing process. 3D printing is its own manufacturing style, so it deserves to have its own part design activities as well.
Yeah, this is a concept called design for additive manufacturing. And this is something we pitch anytime we can, that people need to think about it a little bit differently. All the parts in your car were designed to be mass produced in a specific process. 3D printing is a new process and deserves some new design strategies to go with it.
And I suppose, in fact, is there going to be people in the future or next few years who are going to be able to design using 3D printing in that case, but not be able to design for traditional manufacturing because they've learned how to design using 3D print?
Absolutely. Yes.
Yeah, there's that. And there's another little twist on it. And it's a concept called generative design, where you're using artificial intelligence to build a part that fits the properties exactly what you need and nothing more. So what that means is that someone without an engineering background can have software write a part by describing the places maybe like a drill hole would go, or the amount of forces that come on it from a specific angle, everything that you can put into it. So it's a data issue, or data entry issue to create parts at that point. It isn't an engineering issue.
Interesting. And obviously there are many different kind of AI kind of systems at the moment that are taking kind of front and kind of center. ChatGPT, for instance, being one in the UK, which is very prevalent at the moment, which you can obviously input different ideas and it kind of gives you different kind of bits back. And I know a lot of people use that system for coding because straight away, as you said, it's just data. It's just transferring one idea to a code, and it saves a lot of time and energy to do that. So I can see how, if you're not too sure about how to kind of create it or make that file, something that could work.
Right.
Gary, I have an example of generative design. If you could put my screen back up.
Of course, go for it. Yeah, it should be on.
Yep. So what we see here in the top left is a part that was designed for machining. That part shape looks really familiar to us, right? We see parts like that all over the place. And then as we move down, you can see that material is being taken away. To the bottom right, there is only material where it's needed, at the fastening holes, and then as a frame to provide strength to the part. That's generative design.
Yeah.
So it creates a more organic shape, like a tree structure.
Yeah, and it literally grows them over millions of iterations, so that they tend to look like trees and circulatory systems and things like that. It's really interesting stuff.
It's also beautiful, to be fair.
Yeah,
that part in the bottom right is very well suited for the metal 3D printing process that the Virtual Foundry offers. The part in the top right certainly could fit the process. I'm sorry, top left could fit the process. Bottom right is a beautiful part for it.
Right. And you'll also notice the one at the top right uses probably 3 times as much material. So it's an opportunity to where you probably wouldn't make that part out of titanium unless you absolutely needed the properties of titanium because it's very expensive. But the one on the bottom right, you're not using very much titanium. It might be actually less expensive to do it with a superior material.
And I'm guessing, therefore, because you've got less material, it's going to take less time to go through the manufacturing process.
Yes.
Gotcha. Okay. So can you
Gary,
see?
oh, I'm sorry.
No, you go for it.
We've talked about 3D printing in general, and we've talked about how the Virtual Foundry offers metal, glass, and ceramic 3D printing filaments that work in common 3D printers. There's a second part to the process in order for you to get a full metal part. And we talked about it at the opening of the show, and that is the sintering process. So the filaments that we make, and you can see, oh, where can I point? Right here, a spool above my shoulder. That is what we are actually shipping out. The filament kind of looks like wire on a spool, and that is what you're putting through your 3D printer. It's made of standard 3D printing plastic loaded up with metal or glass or ceramic powder. Your printed object has that same ratio of plastic to metal. In order to get a full metal part, you'll put your print through a heat process. So using heat, you will get the plastic out of that part. That happens at about 480 degrees Celsius. And then you'll heat it up higher to get it to those sintering temperatures. And we talked about sintering, fusing the edges of the metal particles together. So once that second heat cycle is complete, now you've got a full metal part that you made on your regular 3D printer, and then you debound and sintered that same part in a regular kiln, like a pottery kiln or a dental kiln. So now you've got a full metal part that you made yourself.
Nice. This has been fascinating. Absolutely fascinating. I've learned a hell of a lot, and it's kind of made me. I've got two people who I know who have got 3D printers. I'm going to go and ask them what they print, and I'm going to start a conversation because I want to find out now. I want to find out a little bit more. So, if I'm feeling like this, and our listeners and watch viewers might be feeling like this, how can they find more information out? And where do they start? Where can they get started with this whole journey?
Well, first, before getting to your metal filaments, make sure you know how to 3D print plastic. So plastic is nice and cheap. It's readily available for 3D printing. So practice on plastic first, kind of get your 3D printing legs under you, and then come to the Virtual Foundry when you're ready to print metal. You can find us at thevirtualfoundry.com. We do have a reseller in Europe that's called Filament to Print. We have one in Canada as well, Canadian Additive. And in the US, we sell directly from thevirtualfoundry.com and also at Matter Hackers. So those are available reseller options today. But we have lots of cool resources and education to help you get started with metal 3D printing on our website. We also have lots of instructional videos and videos that offer other information and videos of 3D printers printing metal on our YouTube channel. Search for the Virtual Foundry.
Brilliant. And all of those links, folks, will be in the show notes. So wherever you're watching or listening, just literally click on the arrow and you'll see the drop down, and yeah, it will all be in there. And because especially with the videos, it would be kind of nice. I can imagine, just going off a slight tangent here, I can imagine people get obsessed with watching the videos of people 3D printing.
Yes.
I can imagine actually some people have probably set up streams on Twitch or various places of watching people. I can imagine that being a thing.
Yes, it's an easy rabbit hole to go down.
Yes.
Yeah. So if you've got time, folks, just dip your toe in. Just look over the hole and go for it. Before we go, Brad, and let's go to Brad first and then Trisha. Have you got any kind of last words you want to kind of let people know about?
Not that I can think of. I think probably the most important thing is that things are going more quickly. They're becoming less expensive. They're becoming easier to use. So where this was very difficult in the past, it just gets less difficult as time passes.
Brilliant. And Trisha,
sure.
How about you?
Yeah, and I'll add that if you are new to 3D printing, you haven't really seen it, take a look, keep your ears open, keep your eyes open. Eventually, everyone will have a 3D printer in their house, just like we have a computer in our house today. It will look different from the 3D printer that's sitting next to me, but eventually we will get there. 3D printing will become a part of our everyday lives, just as computers are today.
Well, you heard it here first. You heard it here first, folks. If you haven't already kind of started to look at it, I think now's the time to start looking at it. We're starting for New Year. Let's start looking at new technologies which are going to be helpful, not just now, but also in the future as well. And also, let's connect with people like Brad and Tricia at the Virtual Foundry to go from there. So, Brad, Tricia, thank you very much for joining us today. It's been an absolute pleasure. I'm sure this won't be the last time we speak about this. Actually, I can guarantee it won't be the last time we speak about this. So thank you very much for your time today.
Yeah, thank you, Gary. It was a pleasure.
That's all right. And everyone watching, thank you very much for watching. It's been a pleasure talking to Brad and Tricia today. I've learned a hell of a lot. I hope you have too. Please connect with them on their socials and their websites. And for everyone else who's watching now, take care, folks. And this has been Gary from The Grow Show. Goodbye, folks. Bye-bye.